We're okay. Wait for it to finish beeping. Here I am. I'm at Mom's house in the kitchen, and just went for a run and have my tea. And I thought I'd help you out with some Calculus 3. So as you can see, I've got the general equation, polar equation for a conic section up at the top of the screen there. And down below, I've got a problem similar to some of the problems from your homework. You'll notice that the main difference between your the general equation and what you see down below in this problem number 14 is this number right here, that 2, and up top it's a 1. Now this is the key to solving all of these problems in your book that are in that section. I think they're numbers 9 through 13 that you have to do for your homework, is you need to transform using algebra. It's just simple algebraic expressions. You're going to transform that 2 into a 1. So the way we're going to do this is you're just going to divide by 2. So we move this up and divide everything by 2. So the new equation is 4 divided by 2 on top. And then that 2 becomes a 1 because 2 divided by 2 is 1. And then you have 3 divided by 2 times cosine of theta. Oops, sorry, my theta looks kind of funny. I'm writing with this stylus, doing my best. At any rate, now that we have it in general form, let me go back up to the general form up at the top. You can see that the numerator is going to have the eccentricity times the distance to the directrix, and the denominator is going to have the eccentricity times the trig function. And so down here, since this 3/2 times the cosine, the eccentricity of this conic section is 3/2. Now just to remind you, an eccentricity that's greater than 1 is a hyperbola, an eccentricity that's equal to 1 is a parabola, and an eccentricity that's between 0 and 1 is an ellipse. And so this thing's a hyperbola, and so we have the eccentricity. The d, the distance to the directrix, is going to be, let's see, maybe I need to make some space here. We know that E times D is 2, 4/2. Let me just go back up here so you can see this. So this 4/2 right here, that's E times D, and you already know what E is. So let's go down and do the math. It's not that difficult. So 3/2 times D is going to be 4/2. And then just solve this, and I think you get 4/3 for D. Now let me just check my book for a minute here. It says we have to find the conic section. We know it's a hyperbola. We need to give an equation for the directrix. Okay, so the directrix is 4/3 of a unit. And if you need to know where that is, go to the very previous page. You'll find it on page 729. And you see that the second picture down, you probably can't see it from my book, but the second picture down has the general form that we're interested in, the one that has a denominator of 1 minus the cosine. And so this thing, the directrix, will be to the left, excuse me, to the left of the origin. So that distance to the directrix, that 4/3, is a distance to the left. So let's see how we do here. That means that x is equal to negative 4/3 will be the equation of the directrix. And then finally, what else do they want? Sorry. Pull this up here. It says, oh, sketch the okay, so we need to sketch the conic. So to do that, you can be quite you don't have to be very precise with this, I'll say that, because we are doing this in polar form. If you want to, you can pull out your calculator and graph this on your calculator. But here's what we know. We know that the directrix is back here somewhere at negative 4/3. You know that the focus of all of these, you're going to have one of the foci at the point, at the origin. And then in this case, since this is a negative cosine in the denominator, you're going to have an arc that looks like that goes to the right. And then since this is a hyperbola, and this is only true of the hyperbolae, there's another arc that goes over here to the left of the directrix. So if this was just a parabola, you would just draw the one arc. If it was an ellipse, you would connect the arc up to make a full loop. But since this is a hyperbola, you're all done. So you're going to do this for all of the problems in that section. They aren't too bad. There are a couple of problems at the end. Do your best with those, but let me give you a couple of hints. When you get to the problem about, which one is that one? I think it's number 26. Let's see. Basically what you're going to do there is you're going to use problem 25, the general equation for the conic section given in problem 25, to find what are called perihelion and aphelion for using that general equation. In other words, just where is the ellipse closest to the focus and where is it furthest from the focus. And then on 27, even if you can't do 26, for sure you can do 27 because that's just a plug and chug problem. You're going to plug in the numbers that are given for Halley's Comet, and you're going to compute aphelion and perihelion for Halley's Comet. Well, that's it. Send me emails if you're having trouble with the homework, and I'll make another one of these cheesy videos. Otherwise, hope you have a great weekend.